Assalamualaikum. This is a video presentation for Mat 272 Introduction to Mechanics for topic Work, Energy and Power. This group consists of three members, which is Muhammad Mahathir bin Ahmad, Muhammad Syamil bin Zamri, and me, Muhammad Salman Afri bin Abdul Aziz. Work done. What is work done? In physics, work done can be defined as the transfer of energy to or from an object via the application of force along a displacement. In its simplest form, for a constant force alike with the direction of motion, the work equals the product of the force stretched and the distance traveled. Work done is a scalar quantity with a unit of joule or Newton meter. The formula used for the work done is work equal to force multiplied by displacement multiplied by cos theta, where cos theta is angle between force and the direction of motion. Let's say if the object moving in the horizontally, so that means we don't need to use the cos theta. Now we will see some situation where there is no work done. The first situation is when the object is stationary. No work is done if the object does not moving. For example, pushing a wall. No matter how many force we exert to push the wall doesn't have any displacement or movement. Thus, there is no work done. The second situation is there is no force is applied. No work is done if the object moving with uniform velocity without action of force. For example, satellite orbiting the Earth from the space. The satellite have a constant velocity and there is no action of force that have upon it. The third situation is when the direction of motion is perpendicular to applied force. No work is done if the direction of force is 90 degrees to the object. For example, walking while carrying a bag. The weight of the bag is pushing downward. However, the action of walking is moving forward. The force and the motion of. Now, we will look at the work done against the gravity and the work done against the friction. Work done against gravity is the amount of force that is needed to overcome the force of the gravity. It mostly happens whenever you try to uplift an object. The formula of the work done against the gravity is given by work equal to mass of the object multiplied by gravitational acceleration multiplied by height of the object from its original position. Work done against the friction is the amount of energy that is needed to overcome the resistance of the material against which the force is applied. It is given by the formula, just same against the normal work. The difference is just the F here representing the frictional force. To strengthen our understanding of this topic, we will look at the example. This example is a 3 kg block has been pulled up 60 meters on a rough plane that inclines 30 degrees to horizontal plane. The coefficient of friction between the plane and the block is 0.3. We need to find the work against gravity and the work against friction. Now, we will calculate the work done against the gravity. We will use the formula which is work is equal to mass multiplied by gravity multiplied by the height of the position. So, we know that the mass is 3 kg, the gravity on Earth of the Earth is 9.81, and the height is 6 sin 30 degree. So we need to multiply all of that and we'll got the answer 88.29 joule or 88.29 Newton meter. For the second question, which is work done against the friction, we will use the work equal to frictional force multiplied by displacement. To find the frictional force, it is equal to the coefficient of friction multiplied by reaction force, or R. They are already given the coefficient is 0.3, so we will need to find the R. From the y-axis, R is equal to W equal to mass multiplied by gravity multiplied by cos theta, and which is mean 3 multiplied by 9.81 multiplied by cos 30 degree, and we will get that R equal to 25.49 joule. Next, we will use x-axis to find the frictional force. With the formula of coefficient of friction multiplied by R, F is equal to 7.647 joule. And from that we can calculate the work done, which is 7.647 multiplied by 6, and the work done against the friction in this question is 45 point.
Okay, next I'm going to present about energy. Energy is a capacity of system to do work when work done energy is transferred from an object to another. Amount of work done is equal to amount energy transferred. There are two types of energy. The first one is kinetic energy. Kinetic energy is an ability to do work by virtue of having speed. For an example, like a speeding motorcycle or a moving car. Next is potential energy. Potential energy is an ability to do work by virtue position or condition. For an example, a suspended weight such as a suspended rubber, and a bowstring. Okay, kinetic energy. Kinetic energy is the energy of an object due its motion. When a force applied on a body so as it to increase its speed, then the work done is measure of increase in the kinetic energy of a body. So, as example of kinetic energy, like the provided picture, which are aeroplane flying, cycling, cars moving, and also a boy kick a ball. So, for kinetic energy has its own formula, which is kinetic energy equals to 1 over 2 mass time velocity square. Okay, let's try to solve one example of kinetic energy question. The question is, what is the kinetic energy for a car with mass 2000 kg moving at 30 km per second? By the given formula, which is kinetic energy equal to 1 over 2 mass time velocity square. So the mass that from the question, we know that the mass is 2000 and the velocity is 30 km per second. By put the information given into the formula, we got that the kinetic energy is 9,000 or 900 kilojoules. Move on to potential energy. Potential energy of a body is the energy stored in an object due its position above the Earth's surface. Example of potential energy, like people pull the string of a bow or pulls the rubber of the elastic, and so on. The potential energy also has its own formula, which is potential energy equal to mgh, that mass time gravity time height. So next, try to solve potential energy example question. The question asks, what is the potential energy of 10 kilogram of rock sitting on a cliff with 30-meter height? So, by using the formula, which is potential energy equal to mass time gravity time height, and insert the information given from the question, which we has 10 kilogram is a mass, and we use gravity is 9.8, and the height of the cliff is 30 meter. Sum it all, and we got the potential energy is equal to 2,940 joules.
Assalamualaikum warahmatullahi taala wabarakatuh. I am Muhammad Mahdi bin Ahmad. My matrix number is 2021882626. So the last topic of our video presentation is power that I will talk about it. So first thing first, work power or simply power is referred to as a physical notion that, depending on the situation and the information at hand, it may have a variety of interpretations. The rate of performing labor is referred to as power. Power can be defined as the amount of energy or amount of work done used per unit of time. Since it lacks a direction, it is present in scalar amount. The SI unit for power is joules per second or watt. A watt is the amount of energy required to perform 1 joule of work in a second. So let's get to the example of question for the powers. So the example question for power is, the question is, a garage hoist lifts a car up to 3 meters above the ground in 10 seconds. Find the power delivered to the car, given that mass of the car is 900 kilograms. So the information given in this picture we can see is the distance is 3 meter and the mass of the car is 900 kilograms. So let's get to the answer for this question. So the answer for this question is, first of all, we have to calculate the work done, which requires the forces necessary to lift the car against gravity. So we need to find the force against gravity using the formula force equal to mass times gravity. So from the information we get, which is mass 900 kilogram, and the gravity is constant, which is 9.81, so we can get the value for the force. So we need to, in order to get the force, we need to uh, times these two things, which is mass 900 kilogram and gravity, which is 9.81, and we get 8,829 newton for the force. So next, after we found the force, we can calculate the work done by using the formula work equals to force times distance. As we know, we get the force from the calculations before. So, and the given information from the question, from the picture, we can see it is 3 meter. So we can get the work done by using this information. So the work equal to force, which is the before, before this we get 8,829 newtons, and distance, which is 3 meter, times distance, which is 3 meter. We get the answer is 26,487 joule. Next, lastly, we can calculate the power delivered to the car from the information that we have calculated before, using the formula power equal to work divided by time taken. So P is power, W is work done that we have calculated before, and T time taken. We can get the information from the question. So we can get the answer by using work done, which is 2,648,488.7, and divide by time taken, which is 10 seconds, and uh, the answer that we get is 2,000 2,648.7 watt. Okay, that's all for the subtopic for power, which is the last topic of our video presentation. Thank you for listening for this subtopic power.